Tuesday, September 3rd, a few minutes before 8 o'clock. We have been having more fires and smoke. Last night, started about midnight last night. I saw lightning off to the south and the west. It's cleared up a bit. Not that you'll be able to see it, but in terms of delineating Canyon Mountain, I was able to make it out by eye. So there's kind of a view in that direction anyway. Observatory set up. The other night, I was getting terrible views of a lot of the globular clusters after Messier 92. I wasn't sure whether or not it had to do with atmospherics or whether it had to do with focus being disrupted by a disconnection of the power cable that runs to the Rev2 imaging CCD and the display. And as it turned out, when I checked the focus on Altair just before aligning to Altair, I had to readjust, but not significantly. So could have been atmospherics, but I sure was disappointed with the views of those westering early summer globular clusters that I toured. And the one thing I want to point out is, even though the views may not have been particularly good, it gives you a relative idea of their size and brightness. But there's a list at the very end of the video that tells you in sequence all the ones you want to look at, beginning right around NGC 6000, which I believe 6081, which I believe is Messier 80 in Scorpius. For those of you who do not have limitations to your sky, you may want to get out soon, however, and begin a tour of them at the eyepiece. Many of those globular clusters should be visible through a 6-inch refractor, and many should give decent views through a 12-inch telescope at about 100 to 150x. Well, alrighty then, let's start with a little view of Messier 57, the Ring Nebula. We're operating at 64 flood and 42 decibels, the equivalent of about, say a 12-inch telescope. You can see a 13th magnitude star right there. It looks fairly bright on the screen, although it doesn't look so bright on the Sony Handycam display. So I bet you we can go another magnitude and a half fainter, which would put us somewhere around magnitude 14.5, which is the a little low in the scale for a 12-inch scope. We should get to about magnitude 15 at what we're now observing at 150x. It's about, it's 9:30 in the evening. Sky dark has arrived, but I am being vexed by smoke. Regardless, I do have the new moon coming up very shortly, and then after that we're going to start to have a little moon wash in the sky. And I'd like to continue with our exploration of the globular clusters of the summer. We began with, I think it was Messier 80, which was about 6092 in the NGC catalog. But what we're going to do now is go to the last study in the previous series, which was NGC 6401. Let's start with that. Okay, here we have NGC 6401. I'll call it the data for you. It is a globular cluster in Ophiuchus, the snake charmer, which of course lies right next to Serpens, which is the snake. Ophiuchus is an interesting constellation because it really does lie along the ecliptic, but for some reason the ancients didn't want to include a 13th zodiacal constellation. Anyway, what you're seeing there is a magnitude 7.4 class 9 globular cluster, 1 arc minute in size, 24,000 light years distant. And looking at that, I would say, yeah, it's about 1 to 2 arc minutes in size. We're at right ascension 1738.36, declination minus 23.54.32. And that's a fairly decent resolution of this globular cluster, because I made darn sure that the scope was in focus before I started this run. Unlike the last misadventure, which probably had a lot of ill-focused stars in it. But at this point, I can't go back and recapitulate the 22 studies viewed then. We can just be satisfied with the data and also the list of clusters, so you personally can go out and seek them out in the night sky if you so choose, have the equipment and the interest in doing so. It's pretty clear that our next study is eclipses NGC 6401 in size, but it's roughly the same magnitude. I suspect the magnitudinal value from the previous study, 6401, is incorrect. Didn't make sense from class, didn't make sense from its apparent size, 1 arc minute. NGC 6402, globular cluster Ophiuchus, is also known as Messier 14, magnitude 7.6, 6.7 arc minutes in size. The stars you're seeing resolved on the screen, now remember, this thing is in pretty good focus right now, are magnitude 14. It's a class 8 cluster, which means a middling diffusion, anything from about, let's call it 4 to 8. Is in the middle of the range of globular cluster density. We're at right ascension 17, 37, 36, declination -3 degrees, 14 minutes and 42 seconds. Not a bad look. I would like things to be a little tighter. I would point out that these, over here on the screen, these multiplicity of similarly brightness stars are actually artifacts that come out whenever you start pushing the shuttle speed and the sensitivity of the Rev2 system to fairly in decent range for astro imaging, real-time imaging, and they have been present on the screen since my first use of it, and we should keep an eye out for them and not confuse them for actual stars. Well, this is certainly an intriguing view. If you can make it out at all, I can see some faint nebulosity and very faint stars on the threshold of resolution. What magnitude do you think those faint stars are? Anyway, this is NGC 6426, globular cluster in Ophiuchus. The cluster is magnitude 10.9, it's 3.2 arc minutes in size. The brightest stars in the cluster are magnitude 15.2, and I would say we are making out a very small number of them there, so that's not bad. This is a class 9, so on the more diffuse end of the globular cluster scale, 65,000 light years distant. We're at right ascension 17:44:54, declination 3 degrees positive, 10 minutes and 11 seconds. And we are barely on the limits of the sky's middle third. So if you're seeing anything at all on the screen, if I see anything on the screen at all tomorrow, I will be actually quite pleased with it. Although I am getting a decent view of some of those 15th magnitude stars faintly, ghostly presented on the TFT model. Here we are getting a look at our first globular in Sagittarius, NGC 6440. Magnitude 9.3, 1.7 arc minutes in size. It's supposed to be the brightest stars are magnitude 16.7. I don't think they're being resolved. I think we're just getting some pixels, and that may have been the case for the last view as well, although those did look rather more than mere pixels that were just pixels of resolution of background illumination. NGC 6440 is magnitude 9.3, 1.7 arc minutes in size. It's a class 5, so towards the more condensed end of the globular cluster range, 26,000 light years distant. Right ascension 17:48:52, declination -20, 21, and 38 seconds. skipped over a couple of 6400 series globular clusters in Scorpius because they were too far south and would have simply disconnected my power cord once again. The next available globular cluster in the NGC series is NGC 6517, globular cluster Ophiuchus, faint, magnitude 10.3, small, 1 arc minute in size. Brightest stars are magnitude 16. It's a class 4, so it's a fairly condensed globular cluster, 34,000 light years distant. Keep in mind, 34,000 light years distant is only like 6,000 or 7,000 more than Messier 13, which is some 25 arc minutes in size. So this is a fairly small, reasonably condensed cluster. Undoubtedly has fewer stars than Messier 13. We're right ascension 1801.50 and declination minus 857.31 in declination. Here we have, after skipping over a couple of deep south Sagittarian clusters, including 6522 and 28, we moved on to NGC 6535, globular cluster in Serpens, magnitude 9.3, 1.3 arc minutes in size. Brightest stars are magnitude 12.8. That blows me away because that means they're only about 3.5 magnitudes fainter than the cluster as a whole. We should be seeing them on the screen. I am seeing a few stars up there, but not getting a good view. Notwithstanding its sky position, it's right up near the celestial equator. This is a class 11. There's only 12 classes. This is a fairly diffuse globular cluster, 22,000 light years distant. Right ascension 1803.50, declination minus 17 minutes and 51 seconds. That's pretty hopping close to the celestial equator, and we're getting only a very faint view of its brightest stars, which is supposed to be magnitude 12.8. NGC 6539, another globular cluster in Serpens, magnitude 8.9, 2.5 arc minutes in size, brightest stars magnitude 15.9, a class 10 at the Great Hercules cluster distance of 26,000 light years. We're at right ascension 1804.49, declination minus 7 degrees, 35 minutes and 11 seconds, and really not getting that good a view. Nice to have turned this one up. NGC 6544, globular cluster in Sagittarius, magnitude 7.5, 8.4 arc minutes in size, brightest stars 12.8, class 9, 8,200 light years distant, pretty close, considering Messier 4 in Scorpius is 72. Hard to understand how this one could have been missed by Messier and Bechet in the late 1800s, even with a 3-inch scope. We're at right ascension 1807.20, declination minus 24:59.53. This one fell in just under my minus 25 degrees limit. There's not too much tension being put on the cable, but I can't go much further south than that. Encouraged by the fact there wasn't too much tension on the cable, I did break the rule and drop below minus 25 degrees. NGC 6553, globular cluster Sagittarius, 8.3 magnitude, 3.2 arc minutes in size, brightest stars magnitude 15.3, and I do believe very close to resolving them. It's a class 11, 15,000 light years distant. So given the fact it's in Sagittarius, it's got about another 10,000 light years to go before it gets swallowed up by the great black hole in the middle of our own galaxy and probably most others. Right ascension 1809.17, declination minus 25 degrees, 54 minutes and 30 seconds. And checking the tension on the cable, I could probably go a degree further south. Well, here's a rather nice globular cluster. I'm sure hoping it is NGC 6626, and that it is. Globular cluster Sagittarius, you might have guessed it, it's also Messier, number 28, magnitude 6.9, largish, 15 arc minutes in size. Brightest stars are magnitude 12, which you should be able to resolve with a 3-inch or maybe even a slightly smaller scope, except for the sky position. It's a class 4, so on the more condensed end of the globular cluster rating scale. 19,000 light years distant, right ascension 1824.32, declination minus 24 degrees 52 minutes and 6 seconds. I do believe I skipped over some 4 or 5 globular clusters that were just too far south to risk. I am going to slightly resynchronize on Messier 28, and then I'll give you another view before I move on. Given the fact that I'm going to end up going further north and things will drift this way, but not much further south, I left NGC 6626 right there on the screen to give myself some vertical latitude. NGC 6638 is a globular cluster in Sagittarius at magnitude 9.2, 2.2 arc minutes, brightest stars at magnitude 15. It's a class 6, 27,000 light years distant. We're at right ascension 1830.56, declination minus 25, 29.55. NGC 6642, globular cluster in the Sagittarius, magnitude 8.8, that's that tiny 1.8 arc minutes, class 4, 25,000 light years distant, right ascension 1831.53, declination minus 23, 28.34. Okay, what you're seeing here is NGC 6656, globular cluster in Sagittarius, otherwise known as Messier 22. Brightest globular you can see from the northern hemisphere. However, if you're up in the Arctic Circle, not so well. This is Messier 22, magnitude 5.2, about the same size as Messier 13, 24 arc minutes in size. Its brightest stars are magnitude 10.7. It's a class 7, so not as an impressive a globular cluster in terms of its reality, since it's only 10,000 light years distant. So it's less than half the size of Messier 13, which is probably somewhere around 250 light years in diameter. Right ascension 1836.24, declination minus 23 degrees, 54 minutes and 17 seconds. And it sure has drifted across the field. I'll resynchronize. NGC 6712 will be our last globular cluster of the evening. It's in Scutum, magnitude 8.2, 4.3 arc minutes in size. Brightest stars are magnitude 3, 13.3, class 9, 22,000 light years distant. Another candidate for may very well have been discovered by Messier and Messiaen in the late 1700s. It's a class 9, 22,000 light years distant. Right ascension 1853.04, declination minus 8 degrees, 42 minutes and 19 seconds. I'm going to look through here for something adventitious that we could go out on. Ooh, that's too far south. That's a globular. Well, there's one that we can go to later on, but we'll start covering these the next time out. Well, this should give you an idea how much error there is in the tracking to the west. Ordinarily, globulars down to about minus 25 degrees. We're ending up there, and look at the Ring Nebula at this point. I will push it further north for our Carpe Noctem, to the top of the screen for our Carpe Noctem view. Well, fellow astrobuds, here is our Carpe Noctem view of the Ring Nebula, 150x. 64 flood, which means typically, let's see, that's 1.25 seconds exposure, stacked 6 times. If you can make out the central star, I doubt it, but I am kind of seeing something there. That's a magnitude 15.5 star. So this would be pretty impressive on such an evening. I have noticed that Real-time imaging is a little less sensitive to sky conditions than you would have if you were observing through the eyepiece of a similar aperture. We're operating at 150x. I consider this roughly 12-inch views of the heavens. This is our Ring Nebula view, and I am going to say Carpe Noctem.